Hey everyone, today we're going to talk about something super powerful, sequences. You know, they're this amazing mathematical tool that lets us find order in what looks like chaos, decode patterns, and maybe, just maybe, get a little glimpse into the future.
I mean, think about it. We see patterns absolutely everywhere, right? In nature, in the stock market, in how fast technology grows. But here's the real question. How do we take a pattern that we see right now and figure out what it's going to look like tomorrow, or next week, or even a month from now? So let's make this real. Picture this. A video game company just dropped a brand new ad campaign. They start tracking the visits to their website and they notice something kind of wild. The number of hits, it's doubling every single day. And you can see that pattern taking shape right away. Look here. On day 1, they get just 2 hits. Day 2, boom, it doubles to 4. Day 3, it doubles again to 8. Then 16, then 32. I mean, the growth is just explosive. But here's the cool part. It's also perfectly predictable. So, this all leads us to the big question. If this keeps up, how many hits is the site going to get on day 31? Now, sure, we could sit here with a calculator and double the number 31 times. But come on, that's super slow, and there has to be a smarter way to do it. And you guessed it, that's exactly where sequences come into play.
Okay, so let's build up our toolkit. We'll start with the absolute basics. What exactly is a sequence anyway?
Well, at its heart, a sequence is really just an ordered list of numbers. That's it. Think about our website hits again. 2, 4, 8, 16, 32. That list is a sequence. Every number is tied to its specific spot in the line. The first number, the second, the third, and you get the idea. Now, to really talk about these things, we just need a couple of key words. Each number in the list, like the 2 or the 8, that's called a term. And our 5-day example, that's what we call a finite sequence because, well, it has an end. But if a pattern could just keep going forever and ever, we'd call that an infinite sequence. See? Simple as that. Okay, so how do we actually use this stuff to predict things? Well, our first tool is something called an explicit formula. And I love this analogy for it. Think of it like a GPS. It can take you directly to any point in the sequence you want to find, no matter how far down the line it is. For our video game problem, that doubling pattern tells us it's all about powers of 2. So the explicit formula is an equals 2 to the power of n, where n is just the day number. So want to find the hits for day 3? You just calculate 2 to the power of 3. Bam, you get 8. And that's the absolute key here. You can find any term you want without having to know what the one right before it was. But what if you don't have that direct GPS? What then? Well, there's a second method called a recursive formula. And my analogy for this one, dominoes. To figure out one term, you have to know the term that came right before it. Just like one domino has to knock over the next one in line. The key idea here is all about dependency. A recursive formula gives you 2 things, a starting point and a rule. And that rule just tells you how to get from one term to the very next one. You can't just skip ahead and jump to day 31. Nope, you have to go step by step. You calculate day 1, then that helps you find day 2, which helps you find day 3, and so on. Probably the most famous example of this is the Fibonacci sequence. You start with 2 numbers, 1 and 1. To get the next term, you just add the previous 2 together. So 1 plus 1 gives you 2. Then 1 plus 2 gives you 3. Then 2 plus 3 gives you 5. See how that works? Every single term is built on the ones that came right before it. It's perfect domino logic. All right, so let's put these 2 side by side to really get it. The explicit formula, that's our GPS. It finds a term based on its position, n. It's super direct, super fast. On the other hand, the recursive formula is our line of dominoes. It finds a term based on the previous terms. It's definitely slower, but it's absolutely essential for certain patterns, like Fibonacci. Okay, before we finally solve our video game problem, there's just one more special tool I want to add to our kit. It's something that pops up a surprising amount in sequences, and it's called the factorial. A factorial, which you'll see written with an exclamation mark, just means multiply all the whole numbers from this number all the way down to 1. So, for example, 5 factorial is just 5 times 4 times 3 times 2 times 1, which is 120. And by the way, there's a special case. 0 factorial is just 1. Really, it's just a handy little shortcut for a very specific type of multiplication. Okay, we've got our tools, we know about explicit formulas, we know about recursive formulas. I think we're ready. Let's go back and finally answer that big question about the video game website.
Now, for this problem, we don't need to mess with dominoes, right? We need the GPS. We need that direct, explicit formula. And we already figured out what it is. AN equals 2 to the power of n. So to find the number of hits on day 31, all we have to do is plug 31 in for n. We just need to calculate 2 to the 31st power.
And the answer is, get ready for this, 2,147,483,648.
Wow, that is just an incredible number. We're talking over 2.1 billion hits in a single day. Now, is that realistic for a website? Probably not, but that's not the point. What this sequence shows us is the absolutely staggering power of exponential growth. This is the exact same logic that drives everything from compound interest in your savings account to how a video goes viral. A simple, predictable pattern can lead to results that are almost too big to even imagine. And that really leaves us with one final thought. Now that you have these tools, now that you know how to define and predict patterns, I want you to look at the world around you a little differently. What hidden patterns are out there, in your life, in your work, or just out in nature, that you can now describe and maybe even predict using a sequence?